Hello guys and welcome back to our lecture series on big data. Today we are diving into PySpark tutorial on Databricks to process text data. We will split a text file into sentences, count words, filter data, and we do many more. Our goal is to process a text file in Databricks, splitting it into sentences using periods. We will count sentences, we will filter for keywords, we will transform text, and we will also analyze word length. So in summary, what we are going to do here, we're gonna try PySpark RDDs and data frames for sentence processing. We're gonna learn transformation like filter and actions like count. We're gonna use Databricks file system and visualization. We're gonna try some features like sorting and word length analysis, and we're gonna try to understand why Spark works for big data. First, why use Spark? Imagine you have a 100 GB text file. Python crashes on one machine if you want to process this huge size text file. Pandas cannot handle big data in memory. And also, Hadoop MapReduce is slow and hard to code. Spark splits data across a cluster, process it in parallel, and use in-memory speed. Spark is fault tolerant, so if a node fails, it's no problem. Spark Lazy Evaluation optimizes everything. In Databricks, you can get a managed Spark setup with a great user interface, file storage, and visuals. So let's fire up Databricks. In the previous lecture, I told you how to make an account in Databricks and how to create one compute, right? So now we have one compute active, right? And in here, we're gonna add one text file. So you go to catalog here, you go to dbfs, and simply you upload one text file here, right? For example, I'm gonna upload this text file Sejong here. Then we go to workspace, we're gonna create one notebook, and we can just change this name as text underscore processing, right? Then in here, we need to import Spark session, Spark context, and Spark count. So what is a Spark session? A Spark session is the entry point for data frame and SQL functionality in Spark. It provides a unified interface to interact with Spark's capabilities like reading data, executing queries, and managing configuration. Then we have Spark context. This is the main entry point for Spark core RDD-based functionality, and it is responsible for connecting to a Spark cluster, and it creates RDDs, and also it manages resources and tasks. Then we have Spark conf. This is a configuration object that we use it to set up Spark application properties, such as application name, master URL, and other runtime parameters. We do all these things before initializing a Spark context or a Spark session. So import from PySpark. We're gonna import Spark conf and Spark context. So when you press Shift and Enter, it will be automatically attached to a compute, right? Then in here from PySpark.SQL, we're gonna import a Spark session. That's correct. Then we make a conf. Conf is equal to Spark conf dot set app name. So you can select any app name here, like text processing. And then we make one Spark context. So sc is equal to Spark context dot get or create. And then in here, conf is equal to conf. That's right. Then Spark is equal to Spark session dot builder dot app name that we have generated here into this one. Then here get or create. That's right. This Spark context handled RDDs. So what are the RDDs? In the previous lecture, I explained about RDDs. RDD, or Resilient Distributed Data Set, these are fundamental data structure, and they represent an immutable and distributed collection of objects, and Spark processes them in parallel across a cluster. We're gonna load our file and split it into sentences, right? So our file is in catalog here, and dbfs and Sejong text here, right? Just you click here, copy path and copy path, right? Close this one and then come here. Then lines equal to sc.text file, and just we paste the address of our text file here, right? That's correct. Then we're gonna split this line into sentences where a period is there, right? Sentences equals to lines dot flat map, and in here we're gonna use a lambda function, Python lambda or anonymous function, right? Lambda and line, then here line dot split, and split based on what? Based on dot, right? Then in here we filter them, filter and lambda sentence, then sentence dot strip. This one we want to check the empty one, right? Spaces. Then finally here, sentences dot persist, right? So I'm gonna explain what happened. Some problem here. Sentences. This one should be here. All right, so this flat map function here split lines at periods and they flatten sentences into an RDD. Then we, using this filter function, we filter out empty sentences, right? If there is empty sentence, right, there is nothing there. Then in here, we use persist. We cache the RDD in memory for speed since we will reuse it later, right? We are not going to load again and again. Now we can count our sentences, right? So sentence underscore count is equal to sentences dot count. Then we can print it, right? So print if then total sentences equals to this one, right? Is equal to sentence count. So totally we have 12 sentences, right? This count function is an action, right? So we already learned that in Spark we have transformation and action, right? This is an action and it will compute the number of sentences, right? In Spark, actions trigger Spark's work. This is unlike the transformation which are lazy. Here we're gonna take some sample of sentences. Sometimes your text file is huge, too many sentences, and just you want to take some samples, right? So sample underscore sentences is equal to sentences, and here we use function take, right? And here we can pass any number, right? So this takes grab up 5 sentences. This is safer compared to collect for big data. Then in here we can print, for example, some sample sentences, and then in here for I in sample sentences print I, right? So you can see here 5 sentences has been selected from that file, right? I'm gonna search for a specific word, right? So for example, word Sejong, I wanna take out those sentences which contains the word of Sejong, right? So filtered sentences is equal to sentences dot filter, and then again here we use a lambda function, lambda sentence, and the word that we are looking for is Sejong in sentence, right? That's correct. It's fine. So here we can say filter underscore count is equal to this one, right? This one, how many sentences contains the word of Sejong, right? So this one, then we can print it, right? Print this one. So six sentences contains the word Sejong. This function filter here keeps sentences with Sejong, and this count will show how many sentences has this Sejong. And you can see here again we use lambda function, right? This in Python we have several type of functions. One is anonymous function or lambda function. This is considered as a single expression function, and we use it for creating small and throwaway functions without formally defining them using the keyword of def, right? So just simple functions. Then in here, I'm gonna display as a data frame, right? So display, and in here, filtered sentences, this one, filter sentences, dot again map, and lambda x, and then x, and then we will convert this one to df, data frame, and here, sentence, right? So you can see here, this is data frame, right? So 6 sentences include the word of Sejong. You can see here, Sejong, 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 etc., right? So in order to display as a data frame, we map sentences to tuples, like sentence and something, to avoid type error. Next, I'm gonna convert sentences to uppercase, right? So for that one, define a function process underscore sentence. This is the name of function, and I'm gonna get a sentence to convert. Then return. In here we have a function upper, right? So sentence dot upper. This will convert the lower cases into upper cases, right? Then upper case sentences is equal to sentences dot map, and this one we're gonna call this function here. Then we can display them, right? Display uppercase sentences uppercase sentences dot map. Again, we're gonna use a lambda function, lambda x and x. Then we're gonna convert this one to df, and we name it as uppercase sentence. Some problem here. So here it should be upper. That's fine. You can see all 12 sentences has been converted to uppercase. This map here applies our uppercase function, and the small letters will be converted to uppercases. Again, here we use tuples or data frame to keep Spark happy. And then finally, display shows a clean table here. Sometimes we may be interested in counting all characters, right? So total underscore length is equal to sentences dot map, then again lambda function sentence length of sentence. Then we're gonna reduce it. Do you remember the example that I provided about coin, that we want to deposit coin to banks? Here is the same, right? So reduce, then lambda x and y x plus y, right? Then we're gonna print this one, 2035. So in this line, we calculated the total number of characters across all elements in RDD sentences that we already defined. How? By first mapping each sentence to its length and then reduce or summing them together, right? This map get each sentence's length and then reduce, sum up them together. Now we want to find the frequency of each word in this text, right? It means each word, how many times it has been repeated here. For that one, we're gonna import some library that is called as re or regular expression. So import re, this is regular expression, Python library. Then word underscore count is equal to sentences dot flat map, and then here lambda sentence, then re dot split, and this one here we're gonna use backslash s. This is for spaces, right? I will explain it word by word again. Then here sentence dot lower, because here we don't want to repeat. If, for example, Sejong with a small s and capital S, we do not consider these two as two different words, right? So both are the same. That's why we use sentence.lower strip. Then in here, we go to the next line here, then dot filter, and again, lambda word and word. Then in here, map lambda word and one, and then we will reduce by key, and in here again a lambda function a and b, a plus b, right? Then we're gonna display this word count, and we're gonna convert it to a data frame to df, and the headers will be word and count. So let's see the output. That's correct. This is the frequency of words, right? And so this line sentence dot flat map, this one, this convert each sentence to lowercase, then strip leading and trailing spaces. We do not want to consider the spaces before and after each word. Then we split it into words using regular expression that we already imported. And finally, we will flat all resulting lists into a single RDD of words, right? This filter lambda word and word, this removes empty string that may result from splitting or white space only entries. Then this map lambda word and word one, this transform each word into a key value pair like word one to prepare for counting. Then reduce by key lambda a and b, a plus b, this aggregate the counts for each word by summing the value of identical words, right? For each word that we got it, then it will count one by one. Finally, we have frequency in this way, right? And if you click here, then we can go for visualization, like x-axis is word and y-axis is like count, right? So you can see here and has the highest frequency, or you can change the, the type of your chart here, okay? Or you can save it. This is chart and this is table. As you can see here, this result is not sorted. So how to sort it? So sorted underscore word underscore count is equal to word underscore count dot sort by this function. We use it again, lambda x and x1, then ascending is false, right? In descending mode. Then we can display this one again, right? The same thing we use this one here, the same thing we use here, but this time we use sorted count to df word and count. So you can see here and 17, then this is sorted result. We can save the result, right? So you can see here code. We can go for example, word underscore counts, save as text file, this one, and we can give an address where to save, right? So dbfs slash text processing, right? .txt. When you run this one, if you go to catalog here, and go to dbfs, then you can see here this text processing here. This is the output, right? Okay, that's all for today. So in this lecture, we built a PySpark pipeline in Databricks. We split the text into sentences, we count words, we did sorting, and also we show some visualization. Please try it out and comment your question or ideas below this video lecture. Thank you and see you next time.